expression for competence shift. Today we will discuss scanning electron microscopes, which is also called as SEMs, and some numerical problems. The electron microscope was first developed by scientist Charles Otlag in the year 1948, which is the new one. Student, here in this scanning electron microscope consists of some electron gun and optical systems, anodes, condenser lens, objective lens, and components. Now these are all the some accelerating voltage, which will be operate 100 volt to 30,000 volt. Now this is the resolutions of the microscopes, which is 0.7 nanometer to 5 nanometer. Student, just we have to observe carefully. Just we will provide to some screw gauge that resolution is 0.01 millimeter, right? If you give that once, you are difficult to see the readings. With the help of some lens, we have to observe the readings. This is we can't see in our naked eye. We have to use some specific techniques. In this technique, we have to identify the objects. This is the resolution is important. Now go to the principles. Here, the electron beam first passes through the condenser lens, then deflected by beam deflector, which are located between the condenser lens and the specimens. Now, the object lens is used for focusing the electron beam. The electron beam is allowed to sweep rapidly over the surface of sample. The electron to produce are used to an image the specimen surface. The image signal is collected by the detectors. Now student, we'll go for the cross-sectional view of this. You can easily understand the things. Now this is the fast moving electrons impinging on the objective sample, that is the sample. In these samples, it will be impinging on here. It will be some scattering takes place. Now these are all the possible things. The first one is the secondary electrons. It will be provides topographical informations. That means what are there in the samples and what conditions, surface information, surface morphology informations it provides with the help of detector. With the help of detector, it provides these types of informations. The primary backscattered electrons, which provides the atomic number and topographical informations. It's provide two informations, right? Now the X-ray composition informations. Now this is the help of some another detectors. It provides the compositional information. Students, composition information means, suppose you can take the some of the oxide materials. I'll used to take the titanium dioxide, titanium TiO2. Here there are two elements, right? One is titanium, another one is the oxygens. The composition information nothing but titanium is 1, oxygen is 2. That means 1:2 ratio, it provides the informations. Now this is the expected answer. The researcher, they have developed some crystal, which is whether it is the formation of the crystal, the formation of the materials or formation of the sample, it is exactly the same or different. This purpose they have to use the SEM scanning. Now I'll give the example, that is the titanium dioxide. Expected is 1:2 ratio because that is the TiO2. Similarly, we can take another example, that is SiO2, silicon and oxygens. There are two elements, right? So these types of composition information it will be provided, right? Now take the another arrays, that is the Hauser electrons. This is the Hauser electrons. It provides the sensitivity and composition informations. Here sensitivity means some of the samples, some of the researcher, they have expected the expected sample is smooth surface, rough surface, like that. In that purpose, this information it will be provided. Now these are all the possible informations it will be provided. Student, in the exam, they would ask the question is very simple, 4 marks or 5 marks. Discuss the scanning electron microscopes. Like that they would ask the questions. Just you have to write the basic principles and previous diagrams. That is enough. Now we'll go to the some numerical problems. A beam of X-ray is incident on sodium chloride crystal. The first order Bragg reflection is observed at a glancing angle of 8 degree 35 minutes. What is the wavelength of X-ray? And second one, what angle would be the second and third Bragg's reflection occurs? Now we will take the given data, that is they have provided lattice spacing distance, that is interspacing distance, that is they have provided d, then glancing angle they have provided. Here they would ask the question is what is the wavelength of first order. Here we can just recall according to Bragg's law. This is the equations. Here n first order means n is equal to 1. Substitute the relations. We will get the wavelength. This is the wavelength. Second question is what angles would be the second and third Bragg's reflections occurs. We have to use n is equal to second order case, and simplify the same formula. We'll get this the glancing angle in the second order reflections. The third one is we'll get the same thing, substitute n is equal to 3, we'll get this is the answers. These types of questions asked. Okay, go to the next problems. The Compton wavelength is 0.0242 angstroms. If the rest mass of electron is 9.1 into 10 to the power minus 31 kg and velocity of light in vacuums is 3.8 into 10 to the power 8 meter per second. Calculate the Planck's constant. We can use the basic formula, given data and basic formula, this ones, and substitute all the relations. You will get the Planck's constant. Expected answer is this is okay. Now go to the next one. An incident X-ray that is 71 picometer in a calcite target. Find the wavelength of the X-ray scattered at 30 degree angles. What is the largest shift that can be expected in this experiment? This is the problems. First you note down the given data, that is the incident X-ray which is 71 picometer, which is converted into meter. That's why we have to multiply 10 to the power minus 12. Then to find the scattered wavelength here, we know this some constant value. H is the Planck's constant, m0 is the rest mass of electrons, c is the velocity of the light. They have provided the glancing angle, this is the scattered angles, and incident wavelength they have given. We have to calculate the Compton wavelength, that is larger than the incident wavelength, right? That is the statement. Just you recall the statement. Now expected is this one. This is the after scattering of X-rays. This is the before scattering, incident X-rays. So now here we can also calculate the what is the next ones? The largest shift can be expected in this experiment. That's why here the largest possible thing is when theta is equal to 180 degree. That's why we can take the Compton shift equations and substitute these relations. We'll get the answer. Now we'll take the next one. A photon recoil after striking an electron at rest. What is the change in wavelength of the photons? Not on the given data. Take this is the equations and substitute all the relations. We'll get these ones. Okay. Now take the next problems. X-ray of wavelength is this much, 0.1 nanometer. And this is the problems. Here we have to calculate the energy. That's why we can take down the first is given data. Here we know that recoil electron acquire maximum kinetic energy. In the previous problem we have calculated. When you, that is maximum kinetic energy, it will be occur when theta is equal to 180 degree. That is substitute the Compton shift formula, will get this. Then wavelength, this is the incident wavelength. Now we can calculate the scattered wavelength. This plus this will get here. This is the scattered wavelength. Now we have to calculate the kinetic energy of the electron. That's why we can take here, this is the incident one, this is the scattering one. Take the difference of that, we'll get the, can do the simple mathematics and substitute all the relations over here, get the energy which is in terms of joules. That's why we have to convert it into in terms of electron volt. We have to divide it by this 1.6 into 10 to the power of minus 19 coulombs. That is, which is converted into electron volt 575. Student, now these types of problems they would ask, we have to practice more. Thank you, student. In the next video we will discuss the next chapter, that is the liquid crystal.